Good morning, everybody. We are going to learn today how to use Desmos to graph, make a table, and analyze a function. So to do this, we need to go to desmos.com/calculator, which many of you, I'm sure, are very familiar with Desmos. Your screen should look like this. Now, on this problem, this first problem, we are going to graph this simple function. And we're going to make a table of 5 ordered pairs for this function. So we want a graph and we want a table of 5 ordered pairs. All right, so my function is f of x equals 2x plus 3. So on Desmos, we're going to, in the first box, we're going to type in f of x equals 2x plus 3. Remember on the plus sign on your keyboard to use shift. Make sure that your screen looks just like mine. All right, and we have a graph. So on your paper now, when you do this in your assignment tonight, you need to sketch this graph. And the easy way to sketch a linear is to just connect the dots of the two intercepts. So look right here, the y-intercept is 3, and the x-intercept is -1.5. So on your paper, sketch a simple graph that shows those two intercepts. You go ahead and do that, and I'm going to copy and paste this so that you can see what your graph should look like. All right, so on your paper, you need to make a graph. Just something simple like what I copied and pasted there will work. Make sure that you mark your y-intercept at 3 and your x-intercept at -1.5, and then connect the dots. All right. And that is how we will do the graph. All right. Now, the next thing we're supposed to do is make a table. So what we're going to do in Desmos is we're going to click box 2. And follow along closely because this is where Desmos can become tricky if you don't make things match. Click the plus sign and click table. Now what I want you to notice is that the headings up here of X1 and Y1 do not match what I had up in my box. So what we're going to do, click this X1 and delete the 1. That way it's just an X. Then click over by the Y1 and delete it totally and make f of x just like that. Yours needs to look exactly like mine. Desmos gets a little bit cranky if this f of x doesn't match this f of x up here, and if this x doesn't match this up here exactly. All right. Now, to make this table, you get to pick out the x values. All right. So you are going to pick out 5 x values. Now, my recommendation is to pick out 2 negatives, 2 positives, and 0. So how about -5? All you have to do is type in the -5 in the x box, and it automatically tells you the y value. Remember that f of x is the same thing as y. All right. So I'll pick another negative value. How about -1? And then we always want to use 0 as one of our x values because that's going to tell me an intercept. And then how about 2 as a positive x value? And how about 4 as a positive x value? All right. So there's my table. All right. So all you have to do is now make a copy of this table in your notes. All right, because that's what we're going to do tonight is you're going to graph it and make a table of 5 ordered pairs. So I will screen clip this over. So for that problem, you should have those 2 pieces of information. You should have the graph and you should have the table. And you're going to do that about 5 or 6 times in your homework assignment tonight. All right. Sketch the graph, insert the table that you found from Desmos. That's the first type of problem that you're going to do, and you're going to do that one more than any of the other problems in your homework tonight. Now, let's look at the second one. The second type of problem. I'll give you a second to write this down. Example, describe the x values where the function graph is increasing, decreasing, positive, and negative. Typo there. Positive and negative. All right. And all right, I'll go back to that screen so you can finish writing that down. Describe the x values where the function graph is increasing, decreasing, positive, and negative. Now, I want you to notice something. The instructions say describe the x values where this happens. Describe the x values where the function graph is increasing, decreasing, positive, and negative. So let's look at this graph. Do you see that this function is increasing right here where my cursor is moving? So what we want to do is we want to state the x values where that's happening. Well, this graph goes on forever. So does everybody see that this function is increasing from way over here at negative infinity to 0? Okay, the x values where that happens. It increases from way over here, negative infinity, until the x value becomes 0. Then doesn't it start decreasing? And it decreases from 0 to forever, to positive infinity. So let me show you how to state this. Understanding increasing and decreasing isn't hard, but maybe stating it is a little bit harder at times. So here's what I would do. I would state that it is increasing from, and I need to use my different feature here so that I can use the infinity symbol. Give me a second. Increasing. And you can just put like a little colon, and you can put a parenthesis, and then we need the negative infinity symbol. There we go. But it should have a negative in front of it. Negative infinity. And then you put a comma, and then you put a 0. And what that is saying is that it's increasing. We're working left to right from negative infinity to 0. And I know it's way too big. I always have to make it smaller. Okay, so this function is increasing from negative infinity to 0. We're working left to right. Then didn't you tell me that it's decreasing from 0 to forever. So now we would say it is decreasing from 0 to positive infinity. All right. So that, now notice what we're doing. Again, we are stating the x values where this happens. We never state y values for this. We're just stating, okay, from negative infinity to 0, it's increasing. From 0 to positive infinity, it's decreasing. But wait, we're also supposed to state where it's positive and negative. That's talking about what are the x values where the y values are positive. So look at this graph right here. Do you see that my cursor is following all the places where the y values are positive? You see this? All along that part of the curve, the y values are positive. So we want to state the x values where it's positive. Do you see that's from -2 to +2? From -2 to +2, all of the y values are positive. So to state where it's positive, we'll do that now. This function is positive from -2 to +2. That one's easy. Okay. Now, the decreasing part, aren't there, not decreasing, I'm sorry, where is it negative? Aren't these y values down here negative? And also over here, right? So there's two places where this function has negative y values, from negative infinity to -2, and from 2 to positive infinity. So we need to state both of those. This function is negative from negative infinity, my infinity symbol, to -2, and from +2 to positive infinity. All right. So remember what we're doing. We are stating the x values where this stuff is happening. You never state the y values. From negative infinity to 0, this thing's increasing. From 0 to positive infinity, it's decreasing. From -2 to +2, all the y values are positive. And from negative infinity to -2, all the y values are negative. And they're also negative from 2 to positive infinity. All right. And we will stop there for today. Hopefully that gets you a good start.